You want me to present?
Are you updated? Yeah, do you have it in your?
This is
Iniziativa.
thank you. Yeah, I'm good from the work. I have to go walk from the work. I just need to get up there. We won't be able to see it.
Hello, this is, hello, can you hear us? Okay. We are having little technical difficulties, so just please bear with us.
Hello? Morning. So this is the 6-low working group. We're already a little bit late because of all the technical difficulties, so let's go ahead and start. First of all, are all the blue sheets already in circulation? Okay, excellent. Okay. So we have, let's see, do we have any minute takers, Japper spread? Oh, excellent. Thank you. Okay. This is the note well. Hopefully it's not the first time you see it. Make sure you're well aware of what it means. Okay, thank you. We have not a completely packed agenda, but our discussions tend to expand to occupy the volume given it. So hopefully we'll have a little bit extra time, but anyway, we have presentations as follows: IP6 or NFC, and we have some Bluetooth mesh applicability and use cases, update to ND, packet expiration issues, transmission of IP6 or PLC. Then we have some fragmentation discussion, and finally an update on related standards 15.4, etc., as well as plug test information. Working group draft status since the last IETF in Seoul. We have 4 new RFCs, so congratulations to the authors of the working group for being so diligent. So we have the Etherpad request that went through, the paging dispatch, the privacy considerations, as well as dispatch IANA registry. And currently, soon to be RFCs in IAG processing. We have DEC-ULE in OFF48, so it's taking a little bit more than 48 hours, but it'll be there soon, hopefully. Lowback is already in RFC editors too. And a related draft in about an IE to add to the .15 format is also in RFC editors too.
Gabriel?
Yes?
Suresh Krishnan. So like there's one thing, so Tara just told me yesterday the IE got allocated to us from IEEE. So we're going to make a small change in this draft inside the RFC editor queue. So just to put the number that we got.
Yes.
So instead of saying we're going to request this, we're going to say this has been allocated. So I'll just run it by the working group just in case people want to look at it, but we're going to make that change.
Even better.
Yeah.
That's good news. Okay. Thanks, Suresh. Yeah, I'd like to say a couple of words about the MLE series of documents that we adopted. Was it about a year ago, maybe? We started discussing at least a year ago. So MLE is sort of a complicated story. It was put on our agenda as informational because the intent was for it to go real fast. Jupyter Mesh required it. There was also some interest from Thread. We now know that neither of those panned out. They actually have slightly different versions of it, but regardless, there is no interest on this going forward. And we even had a working group let's call. The revision didn't come through anyway, so there was also some lack of energy. So we're going to be dropping that probably within a few days after we get, I guess, home from IETF. So if you if you believe that should not be dropped, if you know of anybody who's actually waiting for it, interested in it, and know how to solve the lack of energy problem around it, let us know. Otherwise, we will drop it in maybe within a week or so. Other working group documents, we still have the backbone router in the mix, NFC document in the mix, the APND and Bluetooth mesh rule here updates about a couple of those today. We adopted since Seoul, we adopted the use cases and Pascal's update to 6775. And that is the chair's update. So now if we can go to the first presentation, IP over NFC. Let's see. Yeah, here we go.
Yeah, my name is Youngwan Choi from S3 Korea. This is IPv6 over NFC. Next slide, please. Actually, every time I show you the introduction of the NFC, this is the quick introduction. Next slide, please. After adoption of this draft, we had 5 times revision, and this is the fifth. That's the update of the draft. This is about the IID generation according to the result of the previous meeting. I just prepared just quite simple update. Actually, there was a comment from Dave about the previous version of document. Actually, I used that the random value in the context, but this is not properly not used. In the document, I just changed it, just blue box, okay, like the letter sentence, just R with the output value, not random value, which may created by mechanism like hash functions with input values, for example, SSAP and the other value prefix like that, because the fixed address of SSAP is easy and sure to be targeted by attacks of the third parties. And I put some example of the IID creation mechanism, like figure 4. Actually, figure 4 shows the example of IID creation. Actually, the F function means the mechanism to make output value for 64 IID. And the parameter offset I just put, just for example, is the input value for the making the different output values. Next slide, please. And this is the last about this presentation. Actually, we had a cooperative discussion with the NFC forum. After the last resolution at the IETF 97 in Seoul, there's no more feedback from the NFC forum so far. Next slide, please. So I think this time I prepared all of the resolution for all the issues about this draft. So I'd like the working group last call for this time. Thank you.
Any comments?
Can you go back to the formation of the interface ID, please? No, yes, the next, yes, this slide. I'm just, from what I read, the function f here has fixed parameters and then these 6 bits SSA. But, and you say, oh, it's easy to predict what the address will be because, or to, I expect because it's not written to scan all the possible addresses because it's only 6 bits. But then you say, I'm using a well-known function with well-known parameters. As soon as people outside know your prefix, they will know this. And then I get better properties. But you can still scan, do all this computation. If you know all the parameters to the computation, then there is no secret, right? Unless the prefix is secret.
But you know, there's the example with this offset there. You know,
Offset, you know?
in the figure 4,
Okay.
actually I just put as offset. This makes the different out value for this.
Gotcha.
So Dave Taylor, so I looked at this and it looks like the intent is that the term that's used offset in the document is basically the nonce. And so what is important, and I didn't look to see if it actually says this, but offset should not just be a number that increments starting from 0, right? It should be like pick a random number of whatever many bits and that's your bits of entropy and then you can hash it into here. And if that didn't work, then you increment it or something like that. As long as you can't predict the offset. So if you can predict the offset, then it's susceptible to exactly what you're talking about. So it's making sure that the offset isn't predictable.
Yeah.
Yes, if you could please add some text there because it's a bit confusing. And explain that you're talking about a scaling attack. That would help. But
Yeah.
Perhaps the feedback here is that offset is maybe not the right name for it, nonce or something.
So, any more comments? We need a couple of reviewers of the document before we go for last call. Can you get, okay, Pascal. And Dave, would you like to give some more review comments?
Okay, thank you. And Pascal.
Okay. Thank you. And next is DLE Mesh, Carles.
Okay, good morning. My name is Carlos Gomez. I'm from UPC, and I'm going to present the last update of the draft entitled IPv6 Mesh over Bluetooth Low Energy using IPSP. My co-authors are Magdi Darudi, also from UPC, and Teemu Savolainen from Nokia. Next, please. So let's take a look at the status of the document. This draft was first presented as a working group document in Seoul, and the last update of the document is -01. So just a couple of minor changes have been applied in this last revision. So actually, we believe that the document is quite stable. And on the other hand, I'd like to explain that we have a plan for implementation of the document to validate the content. So I'll talk briefly about that as well. Next, please. Okay, so let's go through the updates in this last revision. So the first one is in the section about neighbor discovery. And what we have done here is removing the ambiguity of how we were using the term 6LN because RFC 6775 defines a 6LN as any host or router in a 6LoWPAN network. However, in this section, there are 4 items which describe the rules that apply for hosts and for routers. So items 3 and 4 describe the rules for routers, and items 1 and 2 were actually intended for hosts. However, we were using the term 6LN, so we believe for greater clarity, it was better to replace the term 6LN by the term host. Next, please. So the other update is in the section about header compression. It's just a little clarification, which is written in red in the slide. So there's a sentence where we have clarified that header compression optimization that can be applied in this kind of networks can be applied for packets transmitted, and we have added, but not necessarily originated, by the neighbor of a 6LN to that 6LN. So here is an example with two possible situations where a packet is being sent to node A, which is the destination of the packet. However, the source might be, for example, node B in the figure on top, or maybe the packet source could be some other node behind node B, as in the figure below. So it is that in both situations, this header compression optimization can be applied, which means that the destination address can be fully elided in both situations. Next, please. So we would like to validate the content in this document by actually implementing it. So we have a plan for implementation. So right now we are just in the very early stages of this, but anyway, we thought it could be a good idea to report about this. So first of all, the idea is to start from an RFC 7668 scenario. That's the one which defines IPv6 over Bluetooth Low Energy in star topology networks. So the idea is to reuse those functions that do not need any change for BLE mesh, and then to apply some extensions to those functions that do need some kind of adaptation. So the functions that can be used as they were specified in 7668 are stateless address auto configuration and also the multicast mapping. However, we'll need some extensions for neighbor discovery and also for header compression. So for example, the role of the 6LR was actually not present in RFC 7668 because that was just a star topology network. So we'll need this role here, and also we'll need functionality in this case for a multi-hop topology, such as the multi-hop duplicate address detection, and also multi-hop functionality for prefix and context distribution. Also, the type of header compression that was applied in RFC 7668 cannot always be applied in a mesh setup. So we need also some adaptation in this regard. Next, please. So, well, here are the platforms that we plan to consider. So one option is to use, let's say, normal PCs with BLE dongles supporting at least Bluetooth 4.1 specification. Also, we would like to use Raspberry Pis. However, at this stage, we don't know yet if we may encounter any limitations when we proceed with implementation. And also, here you have the list of software that we are going to use. So again, the idea is to reproduce first an RFC 7668 scenario, and beyond that, on top of that, we will extend the functions needed. So here you have the version for Linux kernel libraries, and kernel modules that are actually needed to start from the 7668 scenario. And finally, well, also would like to make a call to the working group to also try to implement the document. It would be great to have feedback from people who are not involved in the author team. So that's all. Any comments or questions?
Suresh Krishnan, so Samita and Gabe, like, was there any follow-up from the Bluetooth SIG on this?
Yeah. So we contacted the Bluetooth SIG. There was review. There's two basic pieces of feedback that I remember. Carlos, please correct me if I'm wrong. One was they didn't like the name because there was some conflict with the internal name of their project around mesh, which is a different layer mesh. Valid feedback. We took that into consideration, I believe, and we changed the name. The other piece of feedback was that yes, in fact, we were correct in assuming that we did not need anything else from them to support this, other than what is already done via IPSP for 7650, whatever it was, for the basic Bluetooth support. So that support really required the collaboration. It took a while. They got it done, but for this one, it's fine. Anything else that you remember that they said?
No, I believe those were the two main areas.
Samita Chakravarti. So I have some clarification questions for you, maybe starting from slide 3. So here you said you have changed the old 6LN to host. So are those, like you clarified, the situation where it will be acting just as a host, but it's in a mesh. So some of the nodes are routers too. So I didn't particularly go check that section, but I just, it's not quite clear from the slides.
Yes, so the point is that if a node is a router, the rules for the router are already specified in the items 3 and 4 of that section. So we felt it was better to clarify that if a node is a host, then the other items, the other part of the section is the one that applies. So we wanted to make it a little bit clearer in this regard.
And then the next slide, so the destination address is fully elided, and so whenever the source is sending, whether that source is 2 hops away or single hop away, you have always destination address fully elided, and there is no change in the middle, right?
The elision, and that's what is intended with the different sizes of the packet in the figure below.
Yeah.
The eliding the destination address would happen in the last hop.
Okay, I see. Okay, thanks.
Thank you.
Okay. Thank you.
Yeah, thank you.
I'm sorry, this is Hannes. I haven't read the document, but it says IPv6 over the BLE mesh, and when I just looked up the document, it refers to the 4.1 spec, but it doesn't talk about the mesh specification. So is that the name confusion that because Bluetooth also works on a mesh?
Exactly. This is what I was referring to.
Mhm.
They are doing their own mesh.
Yeah.
And maybe this mesh could go over there, so we wouldn't know. It's at a different layer. They took care of it.
Yeah.
Or
So
hopefully they
should-
will someday. But
Wouldn't it be more reasonable to actually use their Bluetooth mesh and then run IPv6 on top of it?
that's possible. You can do that. This is independent or orthogonal to that.
Hmm.
This is that above IP. They're doing it at the sub IP layer.
Okay, so it's the route over route and that type of thing.
Yes. So it's yeah, exactly. It's like having some routing protocol over stuff that uses bridging underneath.
Carrie Lynn, so when we did 6LoW back, the BACnet standards organization made available those pieces of that standard that were necessary for review and implementation. And I'm wondering whether we have the same from Bluetooth guys. Is this alone sufficient to implement?
Yes, this confirmed by the Bluetooth SIG. So that would have been a very good question. Maybe it was asked during when we were developing first Bluetooth or the basic Bluetooth or IPv6 document, because that really required some more knowledge about what they were doing. Actually, required them doing stuff for us and revising. That's why, if you see in the slides, Carles says they require 4.1 minimum, because that's when finally the required support came in from Bluetooth SIG so that we could do our work here. But at this point, they themselves have confirmed we don't need anything else from them, so we don't need their documents anymore.
So as an implementer, I can just pick this up and then go off and do an implementation. I don't need to be reading the Bluetooth stuff. Okay, great, thanks.
Okay, thank you.
use case and applicability.
Okay. Good morning, ladies and gentlemen. My name is Yonggun Hong. This is the sixth row, applicability and use cases. Next page, please. Okay. This is the history and status. We discussed it from IETF 89. So as your individual document, we present it IETF 94, 95, and 96, and 97. And the working group document adoption is done in the last year, November 2nd, and this is the first revision. Next page, please. So since IETF 89, the last meeting, the updates are we include new link layer technology, that is PLC, power line communication, and we add a use case of MSTP, that is the management of district heating, and we also add a use case of PLC, that is smart grid, and we add a use case of IEEE 82.11.4e, industrial automation, and we pick some editorial comment, and two new authors are added, that is Tangi and Tech NS. Next page, please. So until currently in this draft, we have 8 link layer technology, G-Wave, BLE, DECT BLE, MSTP, NFC, PLC, IEEE 82.15.e, and one of the possible candidates is LTMTC. So we have to discuss how to harmonize the LTMTC in our draft. So we will have a meeting with the LPWAN chairs and tomorrow morning. So we try to find some possible way to include the LTMTC in this draft. Next page, please.
Gabriel Montenegro. So I have a question. So all those are known to work already, and we have done previous work. LTMTC, I don't believe we have any work on it. So should we limit it to what is already known to work and maybe, and hopefully being used already, is my suggestion.
Yes.
Because otherwise we could grow the document forever.
Yes, you're right. So I'm considering also the LTMTC is possible to include in this draft. So the selection or decision rule is to 6-row technology could be applied in this kind of the technology. So one of the telecommunication, that is the Korea SK Telecom, they have some prototype of the 6-row technology based on the LTMTC. So that's why we add the LTMTC in this draft. But we need to more discussion. So that's why we have a meeting with the 6-row pen chairs tomorrow morning. Okay, next page, please. So we have the 14 design space dimension, as you like to see. So in 8 link layer technology, we try to describe some the design space dimension of each link layer technology. Next page, please. Okay, so this is the 6-row use cases of each link layer technology. So for example, G-Wave cases, we describe the use of G-Wave for home automation. And for BLE cases, we add BLE-based body area networks for fitness. And for example, DECT ULE cases, we add smart metering. And for case of MSTP, we add the management of district heating. Next page, please. So in case of NFC, we describe the alternative secure transfer with for the healthcare. And use case of LTMTC, we describe the wireless backhaul for LoRa gateway. And the use case of PLC, we describe two examples. One is that the advanced metering infrastructure, and the other is for ASA in smart grid. And finally, the use case of IEEE 802.15.e, we describe P2P communication in closed loop application.
Alexander Pelov. So just a question here, we're talking about LoRa on LTMTC. I mean, can you just give a little bit of clarification of how they work?
Yes, it's the backbone gateway, backbone router. So in network, they use the LoRa. For example, the LoRa was Sigfox. But to connect the outside, the long range communication, they use the LTMTC. In that case, the 6-row technology is used. So the SK Telecom has the prototype of like this. So yeah, that's the reason we describe LTMTC in this draft.
Is the okay? Thanks.
Next page. So after submission of this draft in the 6-row mailing list, the Samita gave some valuable comment. So the first one is that this document is growing too big and we lost focus of it. So I said it's true because we include the 8 link layer technology, so the number is a little too many, and the paragraph is also too long. So we need to how to make a short paragraph. So we must solve it. And the second is the related to LPWAN. So as I mentioned that, tomorrow morning we will meet the Alexa platform to find the other way to LPWAN cases. And the third comment is that the same attribute for all use cases may not required. So we make some table. So make a short and make some the table to compare of each link layer technologies. And the fourth comment is that from the example, it is not clear whether 6-row networks and the node are running in the example. Yes, I agree. So in the next revision, we will focus on the 6-row network and the 6-row technology on its use cases. So in the next revision, we will show what practical use cases using the 6-row networks. Next page, please. And Samita gave some the modification of the object section. So I agree. So in the next revision, we will adopt the proposed text. And the Samita also suggests the change of the title. You know, the current title is the 6-row applicability and use cases. So she suggests the 6-row applicability guideline. I think that the use case itself, it has some concern because we are now developing standard and the technical document. So how to handle use cases as a standard. So the proposed title 6-row applicability guideline. So I'm not sure which one is better. So I'm happy to hear your opinion, how to modify or how to change the title of this draft. And Samita also suggests add a subsection on 6-row adaptation consideration on section 5. For example, unicast, multicast address mapping, and fragmentation and the assembly. I think that, this is good. So in the next revision, I will add more subsection. And finally, she gave comment that the goal of this draft is to hand out an IETF document to non-IETF community to spread the word about the IETF work on IPv6 IETF stack for content networks. So you know, this is the original, the purpose of this draft. So we try to keep these purposes, but during and updating this draft, it is not easy to show how to, some the useful and some the practical text to non-IETF the community. So I'm consulting the chairs of 6th row, and I'm also hope your opinion how to provide some of the useful information to non-IETF community. So next page, please. So this is the next step, our homework. We believe in the next revision, we try to solve this work. That is, the first one is that solve the submitter's comment. And I remember that Pascal Rose gave the DECnet use case is useful, so we refer. And I remember the Sandra gave comment that she insists that the LPWAN must be included in this draft. But as we have a discussion with LPWAN chairs, so we will decide. And security consideration, yes, you know, in this draft we have 8 link layer technology. So you know, each link layer technology have its own security consideration, and we also show 8 use cases of each link layer technology, and each use cases has their own security consideration. So in this case, how to the best way to describe security consideration in this draft? So we will we have to decide which is the best way. And the final is add a table description. So we will do in the next revision. Next page, please. Okay, so I welcome your comment and question.
Suresh Krishnan. So one of the things, like I said at the last meeting as well, and now, so one of the, I kind of agree with Samita's comment that like this is like really creeping in scope quite a bit. And that's going to make it very difficult for me to justify this document to go through the IESG. Okay, so especially since the IESG published a statement around the last meeting timeframe, I just sent the URL to you. So if you want to show that statement, and there's like a big pushback on support documents, okay, from the IESG. And especially a document like this, which can get out of date pretty quickly, people are wondering what's the archival value of this, right? So, so try to keep your scope to something that's going to be useful like a year from when it's published. Because like the way I look at the document right now, it's got stuff, it's probably going to be outdated like the second it's published or even before it's published, right? So I'm just putting this on the table because to set the expectations, right? Like this could go to the IESG and not get published because like people are saying, okay, there's alternate publication mechanisms. For example, you could have a working group wiki in there, or you could just have a draft that's updated, right? But I want you to think carefully about the scope. I'm just going to leave it to the chairs, like to like figure out how to do this, but I'm just giving you this information to set the expectations correctly. Okay.
Okay, thank you.
Thank you.
Claudia Montenegro. So one, yeah, I share that concern actually. Now, regardless of what one's opinion is, one possible way to go forward would be to solve your security considerations question in a way that limits the scope naturally, in the sense that in the security considerations section, I don't think you should go and spell out all the considerations for all the link layers. What you should have is this just talks about other work. For each of those works, see the respective security consideration section in those already published RFCs. We cannot point at an existing security consideration section in an existing RFC, maybe even in an advanced draft, but at least an existing security consideration section, then let's not talk about that technology here. That might be a way to limit it.
Yeah, thank you. I have the same feeling, so I follow your suggestion. So, thank you.
Yeah, when I reviewed the document, I also had a similar feeling that if in the current form, if it won't pass the ISG, or the document is too overblown. So we need to cut down the text and scope as well. And let's see how in the next revision, how it looks like. And I think one good aspect of this document to hand it out to the non-IETF folks is that give some guideline what they should consider when they consider running 6-LoWPAN stack on their layer 2 technology. So there are some bullet points in the design space that would help, and then referring to the existing documents in a concise form and having some tabular attributes for each of those. And we also requested the YSUN and Jupyter Mesh folks to provide us some texts for the actual deployment scenario. So the document should be concise and to the point.
Okay.
I hope that should be.
Okay, so that I memorize your comment. Thank you.
So this is actually an update on not one document, but 3 of them, because we have a set of 3 documents which work together in improving 6-LoWPAN ND. So the 3 documents are now the new draft IETF RFC 6775 update. The text in there is mostly not new. It is a split from the backbone router document, which was already workgroup document. So even if the numbers make it look like a brand new work, it's not. And then we've got this address protection work, which is separate because it's more a security feature, which makes it so that once a device has registered an address, it will be difficult to impossible for another device to claim that same address on the same network. So we enforced first come, first serve, which is the spirit of ND, and make it so that the registrar 6LBR can actually store a crypto identifier, which will be used to validate that further registration, mostly if there is a movement, is actually from the same guy. And then the backbone router is this document we've been working on for quite a while. It's been also stable for quite a while. So let's see what happened to those documents. Next slide, please. So just for history, but most people in this room know that the update is actually extracted from the backbone router. The working group here decided that keeping that big document, which had really two sides, one was changing, modifying slightly 6-LoWPAN ND, and the other was enabling a multi-link subnet with a federating backbone. Those 2 functions did not necessarily need to be in the same document. So we actually did the split, and it took like a few IETFs to get there. And the backbone router actually now depends on the update, because the update modifies the arrow option and changes actually the address which is being registered. It was the source address in the original 6-LoWPAN ND, now it's the target address. That enables a proxy registration. Next slide, please. So the status of the update was just published in January. So now it has text on the UID and the TID, which enable the text on the UID enable the APND, the address protection thing, and the text on the TID enables the registration to the backbone. And then some cleaning up happened, but it's mostly stable. Next slide. And the backbone router, well, the diffs in the backbone router is the opposite of the diffs in the update document. Like the text that was added to one was removed from the other. And the same kind of cleanup about reference, like IEEE references, happened as well. Next slide. And then the address protection is brand new. Beshat, if you have any comment on that. But that basically it was just adopted, and as the working group expected, we have published a 00, which was the exact copy of the personal submission. Yeah.
Just can I say a few words about the draft? We are trying to get review. Yeah, Bashar Sarikaya here. We are trying to get reviews for this draft, and I personally approached Thomas Ora, who is now a professor in some university in Denmark, I think, and he would be a good expert, but so far received no reply from him. So we invite everybody to please read and comment so that we can revise and then advance the document.
Next slide, please. So the big question is, where are we going with these documents? So my point of view as editor is that the update and the backbone router are quite stable. They have been implemented. They have been tested at the ETC Interop. There was no major change suggested since the last publication. So I think it's time to do what we do usually, which is find one or two reviewers or three who would accept to go in depth into this document and consider last call.
Suresh Krishnan. So regarding these three documents, right? One thing that concerns me is like it's not clear like what somebody needs to implement, right? Like so, if you look at AP, like there's not enough guidance in there to see like if it's useful for you or not, right? So you say like, hey, like we're better than send. That's pretty much what it says. It says, hey, we're better than send, and we save like this many like bytes in the packet or kilobytes, whatever, right? And that's it, right? So it becomes very difficult for somebody doing an update to like 6LoWPAN ND to figure out like what they need to do. So my question is, like, or my request, like, is to let the working group figure out what is needed and fold them all into an update. That's what I think I would prefer. Okay, so take like if the working group thinks this is important, like fold it into the other update document, or like if it's not important, throw it out, or like make it a May or whatever. But like just like it's already the document roadmap is pretty confusing for like in this space, and we don't want to make it even harder like for people to figure out like how to do this. We don't want to do like another IPv6 for constrained nodes requirement document when we have like an IPv6 requirements document. Do you understand my drift?
Yes.
Okay,
so
I'm just giving you a suggestion. Like I'm not saying this as AD. I'm just saying think about it, because it is going to become difficult for people to figure out what to do. Okay.
Let's take it to the mailing list. You see the problem. One document is stable, the other one is brand new. The use of the second document is to be assessed. So folding it now would be premature. So we need that discussion.
No, I just want the working group to have that discussion to see if this is like something that you want to have in the spec or not.
Okay.
Eric Nordmark. I mean, yeah, I think that assuming down the road, I think it would make sense to actually have a document which is the actual BIS 6775 BIS with whatever we decide should be there, right? But for the time being, I think it makes sense to work out the details on these tweaks to it, or extensions or additions or whatever, independently, so that we can make sure that they're sort of well specified, and also seeing how much interest is there in each one of them before we say, are we going to decide what we're going to put in the actual document that takes all of 6775 and adds and tweaks some things, right? As opposed to doing that up front, because then we have to work with this larger document, and it gets more difficult to gauge what do we have consensus on putting in there as opposed to leaving out, right? And maybe that could happen before this becomes an RFC, but it's actually easier to gauge what are people interested in by having things be separate for a longer time. That's my thinking. But I agree that for someone implementing it, we need to make sure that the relationship is actually clear, right? And showing this is actually an optional piece, and this is, I mean, at some level, they all sort of, we still have to have backwards compatibility for things, so they have to be optional, but making the picture clear.
Okay, thanks, Eric. Like, I really don't mind like working on this like separately, but at some point I want some clarity. Okay, and hopefully before hitting the IESG, but even not, like I would still like the working group to think about it. Okay, figure out like how these things work out. So it could be like a something that ties together or more text in these documents, like showing how they relate to each other and to 6775.
Yes, so how they relate can be, it's easy to fix, and we'll do it as next days. Progressing security for a little while by itself is good because we'll probably ask reviews from security people who really don't care about, some aspect of the rest of the work.
So maybe. Samita again, just asking Suresh. So do you think that this all three of them should be one document? But I think backbone router is a special deployment case, so that would be separate, and the two others could be merged.
Suresh Krishnan. So I was specifically asking about APND, right? But I still want the relationship between the documents, even for backbone router and this. Because this is going to end up updating 6775, and there's been a lot of confusion about what updates means, and this is not specific to this group or even this area. People are still debating what updates mean, and we don't have a very clear definition, right? And people are looking for more clarity on how that update actually works, right? Because some people use update as see also, and some people think of them as changing text. People are looking for what text are you changing, and I really think there should be some clarity on how these things relate.
Yes, so we'll see in the text of the APND. The fact is, we made updates so that the unique ID did not have to be a MAC address, right? And once we open that door, then APND comes in and say, oh, in my case, it's not a MAC address.
Yeah, and it doesn't have to be in the IID of the address, right? And that's also another thing, right? Compared to CGA, right?
Yeah. But we had to open that door in ND so that APND could use it.
Okay,
that's the relationship. So.
Lorenzo Coliti, I wanted to make a comment about the applicability statement. Sorry. Lorenzo Coliti. I would like to make a comment about the applicability statement of 6LoWPAN-ND. Right, so this draft is adding the extended registration option, which includes the response code administrative rejection. So, the address being registered is reserved for another use. For example, it's part of a DHP pool or something else. So, at the same time, the draft also says that the neighbor discovery optimization suggests that 6LoWPAN-ND can be extended to other types of links. I think we should say here that this guidance actually conflicts with the best practices for IP address allocation defined in 7934. And so we should make sure that we have an applicability statement that clarifies that. So we should say why these, so we should say why these types of links require that the network be able to deny IP address formation to the nodes that are on it. And in these link types, there are efficiency reasons for that, and we should say that. But we shouldn't make a more general applicability statement about 6LoWPAN-ND because it violates those best practices. For reference, 7934 says, I can read it. It says, blah, 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 blah. It is recommended that the network give the host the ability to use new addresses without requiring explicit requests. Now, if an address registration option that says, I have this address, that can cause a reply of the form administratively rejected, no, you can't have it, is an explicit request. Right? And so we have to clarify the relationship between that. Now, one thing that we can say is that 7934 only applies to general purpose hosts. So we could say, well, this is not intended for general purpose hosts. That's probably not what you want, I expect. But then we should say that on particular link types, there are very important efficiency reasons that override these general recommendations, and we should explain why, and properly scope whatever we do, and properly scope the applicability of 6LoWPAN-ND to ensure that we don't end up using it on links where that trade-off is different.
Yeah, we have to craft that work, that text together. I see what you're going. Basically, the first thing we need to do is reference the RFC and say, oh, there is this general case and this general recommendation. It is this draft cannot study the future of all the Fed buildings which are coming in, and which one will fall down into this bucket, which ones fall into the other bucket. It's going to be an IP over foo decision. We just say, oh, that's one thing that exists. It's designed for this kind of constraint. When you do your IP over foo, consider this work, consider the RFC, look at why the RFC makes its recommendation, and make your decision as a working group. We are not saying use that in that other link.
Okay, go, you go.
Eric, not Mike, but I don't even know. So the particular concern is the administrative rejection code, right?
Well, so
Or is it more broader one? I mean, we
the
clearly we can
text, the 7934 talks about explicit requests. Now, somewhere where I say, I have this address, please register for me, and the network can say no in any way is kind of a request. That's my point.
And so is the multicast DAD message, because it can say no, and the party that says no is different, right? I mean, yes, there's a registration piece here, but there's also a DAD piece, and I think that
But
you know
if
the explicit the administrative rejection, I don't think we actually need that one, because it's not something we have elsewhere. We don't have that in the multicast DAD case. There's no way for someone to say, oh, you shouldn't use this range of addresses because they're part of a DHCP pool. You have to figure that out through how you actually form the addresses in the first place, right? With the various bits in the addresses, so which we already have, right?
So should, if we remove text about administrative, does that solve the problem?
Well, I think we need to add references saying that you shouldn't abuse this thing as well, right? With a reference to the RFC, but.
Well, there's also the fact that there's also the fact that there are nine rejection codes at the moment, but they're all sort of, you're on the wrong link. This is not the freshest registration.
Well, the freshest registration is really intended to the 6LR. But yes.
But and my point is, anything where I can say I want this, and the network can say no for a variety of reasons, including new reasons that can be defined in the future, right? Because there's just like from 0 to 9, presumably there's the possibility of finding other ones. That to me is a request, and so that is very different because it is specified for only the case where there's another address. And if you misuse it, you are actually violating the RFC. If you're saying, okay, well, I want to deny your ability to form an address, I'm just going to pretend that everything is a duplicate, that's not DAD. That's an attack, right? So here, actually, what we're doing is we're defining a way for the network to say no, and so we're actually providing a standard for that. And that is something that we have to clarify again. To me, that's a request. DAD is not a request. DAD is basically like a failure mode. Now you can abuse that failure mode to cause a denial, assuming that packet gets there, because there's only one packet. But this is very different.
No, Lorenzo, let's just to show you that it's not white and black. This particular code that you said, it's not the freshest. The use case is unusual. So you can refer to the RFC, and we will do that, so beware. But the point being that if a node moves inside the network, makes a registration this way, then moves and make a registration this way, there is a state in this 6LR which may be installed, and you need a response to clean up that state. It's new, it's still dead. You see, it's not a network rejection. It's telling the 6LR, this rejection, this registration, forget it, it's lost, you see, so we have to have some code like that, and that's still part of that. It's not white and black. Okay.
Are you saying this is not a request then?
Yes, I mean that's part of that. This particular example is part of that because we have a state installed in the network that we need to clean up. The device started the registration process and moved, and now a 6LR is standing there with some state.
What about invalid register address? What about there's I mean my point is there are lots of codes. Are you saying that this is so? I guess the question is, the terminology in 7934 is request. Are you saying this is not a request? You're saying the ARO option is not a request. If you say it's not a request, then you can argue that 7934 doesn't apply. If you're saying it is a request, then we have to clarify what that means. That's my question.
Okay, Suresh Krishnan. Lorenzo, I think you're reading something a bit too literally. That's what I think, okay? So imagine you have a PIO with like, forget a 6LoWPAN link, a regular link, okay? You send a PIO with prefix P1, and I form an address with like prefix P2, and send a packet to you as a router. What do? Exactly, and that's what is invalid address. You're using an address that's topologically incorrect for the link, okay? So the only difference is you're trying to register with the router, and the router is telling you up front that, like, I'm not going to let this packet pass through. That's what it is. So it's not like a request for you to get the address. It's a request. The router is providing you a service, and it can say yes or no for that. It's not telling you not to form an address. So if it's ever used in a mixed link, and again, I think that's also literal, because the other link type specified is for not 802.15.4, but other things, okay? So 6LoWPAN has kind of moved to other kind of link types, for example, like LoWback or ULE and stuff like that. So I think it's in some of the document, it actually lists the set of things as examples, but, right?
I mean, this would cover 802.11, for example, if you read this text.
Right, but there is another document which actually lists like a bunch of things as examples, and you will see that, okay? But this one, I don't see this as like request, like you getting permission to use that address, like you're asking them to request to, like, do the 6LoWPAN ND for you, right? And at that point, they can say like, hey, you're using a wrong address. Like, this doesn't make sense on this link. And so the administrative, I agree with you. Other things, I don't. Okay.
We should probably take this offline, but I think we should figure out some text that makes this clear, that this mechanism shouldn't be used for administratively denying people to form addresses, right? And we don't have to get into the details to think about request versus not, but that's not the intent of this. It's more about, yeah, you're registering something so that you can handle the DAD thing, but also so that in the case of backbone routers, people can find where you are, right? A routing function. And then there are these other sort of error codes that say, but wait, this thing you sent me and asked me to do doesn't make any sense, right? Because the address is invalid. It's not on the subnet you're supposed to be on, right? And those are useful informational things. But I think making the intent clear, up front, figuring out the right place in the document to actually make that clear, saying, this is not to deny people to form addresses. It's actually make sure that they can form usable addresses, as opposed to trying to use ones that are not in the subnet, right? Or somehow being confused because of some stale state or whatever, right? So make sure that things can converge.
Christian Wiedemann. I am working on a privacy issue with addresses. And one of the critical part of privacy issue with addresses is that basically stations can create new address based on privacy events by just picking a random number. And anything that is not, I'm picking a random number based on some algorithm I'm choosing, then if you are going to prevent that, then it's an issue, okay?
We are not preventing anything like that. The only constraint that exists in 6LoWPAN is not at all due to this document, it's due to the compression, which basically says you have to decide whether you want to have a stateless compression of your interface ID, in which case it has to be, there must be a way to infer it from the MAC. So it might be a direct copy or it might be some logic, but there must be a way to infer the interface ID from the MAC. In that case, you can elide the interface ID from the IPv6 packet, but it has nothing to do with the registration. You can register anything as long as, but you can't register unspecified, right? It is invalid.
Basically, anything that goes in the way of allowing temporary addresses that have no relation whatsoever with topology, internet, the prefix association is topology, but the MAC address, the IID does not. So anything that goes in preventing that goes against the general architecture and goes against the privacy direction.
Yeah.
So that includes the compression stuff. Basically, we should work out the compression so that if people pick random number, it does compress somehow.
Yes, and I believe there is work to be done in this group to actually do that. It's very much outside of the work of this document, but yes, the compression today has this sort of assumption. If we could make something which is at least private to the subnet, so that when the packet gets out, it's more private, and probably something can be done in this group. Yeah.
Just to say something at the mic that Suresh just pointed out to me. So he said, by doing ARO, you're requesting that the network give you a service, which is to find you or do that for you. That's an important point here. I think the difference is if you're just requesting a service and your address will work even if that registration fails, then it's not a request. But if you request a service of address registration, and if the answer is no, then your address doesn't work, then that's a fundamental difference, I think. That would be the bright line that I would draw. Like if I do ARO, if I form, like Christian said, if I form a new IPv6 address with whatever random number I want, if I do ARO, and the answer is like, for example, like the ARO version, like the non-extended ARO has the code neighbor cache full, right? So say I get like neighbor cache full, is that address still valid? Can I use that, let's say, later on, for example? If it's guaranteed that I can't use that address, or if there's no, basically, if the network has told me, yeah, you're not going to be able to use it, then in some sense, I think that's a request. If you can use it and it's just like, well, it might work, probably, it's valid, then it's not. But I think my understanding is that it's more along the lines of if IRO fails, it's not going to work at all.
Okay, Suresh Krishnan. So Lorenzo, right? It's a give and take, right? Yeah. Okay, so you ask a router to do something for you, and in exchange, you get a benefit of going to sleep, and your address is still fine for you. Okay.
Is that something you can choose to avoid to do?
No, hold on. So if you implement only 6LoWPAN ND, then you cannot do anything. Okay. So imagine a node which has like 6LoWPAN ND and classic ND, and if the ARO fails, it can drop down to classic ND and do its own thing, right? Nothing is stopping you from doing that. But because of the constraints on the devices, it's probably not going to happen. So it's going to end up what you're saying, but not by design. It's because the nodes decided, like, if I cannot do this, I cannot continue any further, or the node makes the decision, right? So if you're on Android, you implement both 6LoWPAN ND and classic ND, you can say like, hey, my ARO failed, but I'm still going to use the address. I'm going to drop down to classic ND, do my DAD, see if it's fine, and then I'm going to defend it myself, and I cannot go to sleep because I need to defend my address, right? That's the decision you can make on the node yourself.
Do we have a spec about how mixed classic ND and LoWPAN ND works? Do we know that it works together if you run both of them at the same time? Do we know? No. Oh, so then it's not a choice you can make because it's not even defined, right? You can't actually make that choice.
Dave Taylor. So I agree with Eric's response that this is a little bit like DAD, and I think his suggestion was maybe the document should clarify what kind of is appropriate or inappropriate uses, and to say that you should only reject if you would have rejected DAD. But no, you don't reject DAD. Because part of your draft is saying if you're just a router, you shouldn't just say conflict, 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 conflict for every rest they have. The ARO, the administrative rejection, it talks about being, oh, well, this is reserved out of the DHCP pool or whatever else it is, right? So if it actually had text that says you shouldn't reject stuff unless you would have rejected DAD for the same address, which is perhaps a stronger statement than what Suresh is saying and giving an example. Okay? If it said that, then it's certainly no worse than DAD, and then it does have to comply to the BCP that 783.
But there's more to it, like the example I gave.
I think I like Eric's response, and I agree with what he said. I think there are ways to address that because I do see it, as Eric pointed out, it should be treated very similar to how you treat a DAD response, and a router could do bad things with DAD too.
That's not what it says.
Yeah, I know, but I'm saying that was a suggestion, was to add a text along those lines, right? That's what I thought Eric said.
I'm going to cut the line right here because we need to move.
The line doesn't get any longer. It's the same people. But
Yeah.
So it doesn't help. But yeah, just to point out that there are other services other than the duplicate check. It's the thing that you're pre-populating the stuff into the neighbor cache, so you don't have to necessarily deal with neighbor solicitations, or you can implement things like backbones, right? And that's a service that if that table is full, the router can offer it to you, right? But you should still be able to send using this as a source. But if it doesn't have anything in its neighbor cache for you, it can't forward packets to you. But it could choose to not forward packets to you because of the TCP port number, whatever, right? And we shouldn't we should point out that this is not the intent, right? That you're actually in violation of the purpose of the specification if you do those types of things, right? And I think that hopefully that can go a long way to say, no, this is not actually here for you to be able to control which addresses people use, because as Christian pointed out, you need to be able to form privacy addresses. You need to be able to do all of these things. This shouldn't get in their way. This should help hosts to be able to go to sleep and do that more efficiently, not prevent hosts from communicating, right? Oh, yeah, I know. And we'll figure out that text, yes.
Suresh Krishnan, last comment. So regarding the mixed stuff, right? The closest thing we have to describing mixed operation is like Eric and Samita's draft in 6-man. So like maybe we can continue the discussion on the draft, because it is like expected to work on whatever kind of link, and it really has to handle this like failures and moving over. So maybe if you guys decide to ever revise it, like to continue the discussion. Yeah, exactly, right. Like, so if you want to like talk about like this, like maybe that would be the draft to talk about it. And here, like, I don't think it's in scope for 6-low. And I do acknowledge all of like Lorenzo's concerns. I think we can work out text for that. I don't think there's an intent to like screw people out of addresses.
Okay. Let me finish the session right now. I would like to ask a share request. I mean, not that I enjoy these interactions, they're very entertaining, but we had one already in Seoul, and I'm not looking forward to another one in Prague. So if we could make a concerted effort to have text along the lines of, there were pretty, some good suggestions here, before Prague, that would be great. So work intensely, like a little design team or something, report back to the mailing list, so that before Prague we have something that passes muster, or has a chance of passing muster. That would be great.
Next is Charlie. Right, sorry, we need some reviewers for this 6-low, and there are 3 drafts. So we need reviewers for 3 drafts, especially the comment is for the 6-low and ND, right? So, okay, we need actually, right now I think we need to, the co-authors should work with Lorenzo and Suresh and others, and then have a document in next time, and then we will find reviewers. Yeah. Okay.
Well, while they're finding it, I'll just give a little brief introduction. The idea is that we want to allow for a deadline or an expiration time, so that when a packet is delivered to the destination, it can, or even in transit, it can be discarded if it's not going to be useful when it arrives. And the way to tell if it's useful is that if it's going to be there before the deadline. So basically, that's the underlying idea of the draft. And we have submitted this a couple of IETFs ago and made some significant changes to it. So there we go. Okay. So you already have the summary of my presentation. So one of the requirements for this to work is for the network to essentially be synchronized, so that you can actually tell that the expiration time is in common understanding between the source and the destination. So this is an elective routing header, and it always carries the expiration time or the deadline and it can optionally carry the origination time, so you can tell information or maybe even keep statistics about the amount of time it takes to send packet from source to destination. So the idea is that we have this delay-aware operation, and this draft was augmented a bit to allow for moving between networks that are synchronized but still are not using the same understanding for the current time. Next slide, please. So from the last IETF, we had comments from people that looked at the draft, and so was the routing header. What we decided we were asked to use an elective header, which makes sense, and added the optional ability to include the origination time. And a pretty significant change was to enable the expression of the expiration time and origination time in different time units or time scales. So that actually added a bit of text, which I'll explain shortly. That's the compressed time representation, and then renamed it from being a timestamp to being deadline, because the deadline is actually the point of the draft. And so thank you for Pascal Thomas and Dale for these comments. Next slide, please. So here's a picture of the packet format, and so on the bottom you'll see that there's all these fields which we've defined to make this time compression scheme, and another scaling factor using the EXP field there at the end. And so given the compression scheme, the origination time and the expiration time become variable length fields. Next slide, please. So there, the length, the first length there is the number of octets in the elective header, and then the type field, the origination time field, it can be present or not, controlled by the O flag, and then there's a D flag that expresses two different treatments for the expiration elective header. One, if it's expired, you have to drop it, and then if the other one is that it's not expired, you can still ignore it, and the fact that it's expired, and send it along just in case it might be useful even after the deadline. So I think it remains to be seen if that has value for actual use. And then the ER field, as you can see, shows some possibilities for the units for the time. And so we have here either in microseconds, milliseconds, or in seconds. Yes, question?
Yeah, Dr. Montenegro. Looking at the ER field, the user defined, how do I guarantee interoperability using that field?
Well, I think user defined in what sense? I mean, if you have a packet that says that the expiration time or deadline time is measured in the number of microseconds, then that's what the receiver will interpret it to mean.
Yeah, but if the field says 1-1, it's neither micro, milli, or seconds. It's user defined. So how do I interoperate?
Okay, I'm sorry, I didn't understand your question. Well, so we don't have an answer for that question. So we need to do something about that.
Okay, like not using it would be a perfect option because you can interoperate. Or you would need another document to define user-defined things. And
I think the USER may be a typo. It should be UN. But we'll get back to that. Okay, thank you. And next slide. Okay, so this is pretty straightforward, I think. So those variable length fields for the expiration time and the origination time are controlled. This will tell you how long they are in octets. So we can express values from 1 to 8 octets. given the 3 bits. And similarly for the origination time length, there's the same scheme for that. There are 2 reserved bits, and plus there's a way to say that the time that's in the fields has to be multiplied by some power of 2 using the EXP field. And then, of course, after that, we have the actual values in this compressed time scheme. Next slide, please. So this is just about how you packets are forwarded between domains that have different ideas of what the current time is. And so basically, the idea is that, you have to, anyway, for anything to work here, it has to have some sort of synchronization. And then on the when a packet is delivered into the domain with the new current time, you basically have to subtract off. Well, the origination time in the new network is the same as the origination time in the old network, plus essentially the difference in the ideas of the current time. And you can express that in this way also. Next slide, please. So that's pretty much it. There's, I think, a little bit more work to do in the draft and another editorial pass, but it seems to be pretty short and expresses a useful need. And I guess we do have to figure out whether we want to decide on a registry of user-defined values or have some way of assuring interoperability. But other than that, one question I guess we would like to ask is if that compressed time scheme, should we have one of the values be for ASN to sort of work better with 6-tish perhaps, or is the existing set of timescale units sufficient for the need? Yes, please, Carrie.
Carrie Lynn. So Charlie, your designations for units increase in the first 3 cases and by 3 orders of magnitude. Do you expect user-defined to be anything larger than hours? Why not just declare it to be hours? Just throwing that out there.
I'm going to be brutally honest. We didn't really discuss that very much. But I wanted to also point out that given that you have the EXP field, you can express pretty large values of the time units. I mean, for instance, 8 octets of seconds times 2 to the 7th, you're getting pretty long here.
Pascal Hubert, Charlie, is there a intent to actually use this mechanism as well for, because it's a routing header, right? For the purpose of, let's say, route this packet differently, because if it's late, maybe you should take a shorter path, or do different cross, like I have this queue of packets and some are late, some have time in front of us.
We don't have any explicit designation on how you relate a particular expiration time to a QoS, but essentially you can imagine that such a thing would exist. And if you want to have voice conversation and try to make sure that the packets arrive in 50 milliseconds or something, I mean, that's pretty simple computation.
Because just leaving this packet at the end of multiple queues and then it dies, as opposed to maybe speeding it a little bit because it's late. That's a different service from the network. I see a lot of value in doing that sort of thing. Actually, I'm aware of IPR about it. But yes, I think we can, this is great work and it can even be taken further. That's what I'm after.
Okay, yeah, thank you. Well, I think we made up some of the time. Any more questions? Please take a look at the draft. And if I think it expresses a useful need, I would like to ask if it consideration for adoption as a working group document, and we certainly will continue work on it.
So how many people have read the draft? Okay. 3, 5, 4. Okay, so so definitely we need, okay, 5 or 6. Okay, so please continue to work and we need more reviewers. Please provide comments in the draft.
Okay, thank you.
It's so hard for me. Okay, so good morning. My name is Jian Chang Ho, and I'm working for Huawei Technologies. Today, my topic is transmission of IPv6 packets over PLC networks. This work was done by me together with Donggen Hong and Xiao Juntang. I put this draft online this month, and hopefully some of you have read it. Since it is the first time I present this draft, I would like to first briefly introduce PLC. Okay, next please. So PLC refers to power line communication. This technology uses the electric power lines for indoor and outdoor communications. PLC enables chameleon two-way communications and has been widely applied to support the advanced metering infrastructure, namely AMI. So nowadays, smart meters have been deployed all over the world, and the meter readings can be transmitted to a concentrator directly through the power lines and then uploaded to the data center. So here is an example of the PLC network, and I guess many of you have witnessed the evolution of smart meters in your home. Okay, next please. Actually, this area is follow different PLC standards, and the purpose of this draft is to facilitate the selection among these standards and to guide the deployments of IPv6 packets over PLC networks. So this draft uses such protocol stack, and the general approach is to adapt the 6LoWPAN. So the general approach is to adapt the LoWPAN elements to the PLC networks. Well, by now, two PLC standards, namely IEEE 1901.2 and IETF G.9903, are included respectively because they are quite different. For example, 9903 uses a mesh under routing protocol called loading, while 1901.2 uses a route over protocol called repo. But well, actually 1901.2 also has an interworking mode to support the use of loading. Okay, next please. Well, following are some key issues in this draft. First is fragmentation and reassembly. In IEEE 1901.2, since the MAC layer supports AMTU of 1576 octets, that is larger than the required MTU by IPv6 packets. So this draft specifies that the fragmentation and the reassembly must not be used at the 6-node adaptation layer. While for the IETF G.9903, since the MAC layer only supports MTU of 400 octets, that is insufficient for supporting complete IPv6 packets. So this draft specifies the fragmentation and the reassembly in RFC 4944 must be provided. Well, it is worthwhile noting that in both standards, segmentation and the reassembly at MAC layer are enabled. That allows the MAC service data unit to be segmented into 5 service data units. So in this case, redundant fragmentation will appear in 9903. That means the IPv6 packets will be first fragmented into the MSDU and then segmented into PSDU. Okay, so I think maybe we can do some modification in the future on this issue. Or after all, it can be a parameter for comparing different PLC standards. Okay, next please. Well, for regarding header compression, considering the limited page and the performance of the PLC devices, this draft specifies that all headers must be compressed according to RFC 6282. Okay, next. Well, at the 6-node adaptation layer, apart from the headers defined in the 6LoWPAN, well, 9903 specifies an additional header called command frame header for the layer 2 mesh routing. Well, it uses an ASC header to indicate there is another dispatch type follows So it is used as command ID, and then here follows the command frame header. So we provide an example of the header formats, including the fragmentation header, the command frame header, and the IPHC header. And this kind of format will be both used in the 9903 and in the interworking mode of 1901.2. Okay, next please. Well, for regarding connectivity and topology, now three topologies are included. They are star, tree, and mesh, and together with some unique scenarios. Well, the advanced metering infrastructure normally forms into the star topology, and for some complicated AMI cases that cover larger areas, the tree topology is also possible. Well, the mesh topology is developing and is of great importance. It expands the size of PLC networks and allows the peer-to-peer communication. So by now, this draft specifies the IPv6 over PLC networks should contain these three scenarios, well, but actually more scenarios can be included in future. For example, now only the scenarios with internet connection are included, but actually the isolated cases is also possible. Next. Well, so by now only a few modifications are included that are based on the low-pan elements, but I think the importance of this draft cannot be ignored because the PLC implementers require a document to facilitate their selection among different PLC standards and to guide the deployments of IPv6 over PLC networks. Well, hopefully this could be useful in this working group. And about the future work, I'm wondering, should we include more PLC standards in the future? For example, the ITU-T G.904, 02, and IEEE 101.1. And about my next step, well, I plan to add a subsection called neighbor discovery. And recently I received the comments from Samita, so thank you very much. And we will reflect them in the next version. And I've also discussed with Daniel Popper. He proposed a similar draft about IEEE 101.2 several years ago, but expired. So let's see, maybe we can update, if any, based on our ongoing discussion. Well, at last, I want to say your feedback is very valuable and will always be appreciated. Well, thank you.
So, Samita Chakrabarti. So actually you have this mesh connectivity diagram.
Yes.
I want to know if the PLC only supports that diagram or they also support extended mesh. If we can go to that slide, connectivities. Yeah, this is the one.
Yes. So these are the common topologies, but I said actually more topologies can be included.
Okay, so for example, you have two diamonds connected. Can you connect more diamonds with them?
Yes.
Okay.
Yes. Yes.
Okay, Montenegro. So, I guess you have not one link layer, but two really, one from ITU, one from IEEE. Are you working in those committees directly? Are those committees aware of this work? What have they said? Any feedback or liaison or whatever?
Sorry, could you please pardon?
So one of the link layers you deal with come from ITU,
Yes.
right? 9903, right? And the other one is IEEE,
Yes.
1901.
Yes.
Do those committees know about this work? Are you involved in those committees directly? What do they think
I'm not
about
involved, but actually recently I've discussed with Samita and we are going to we're going to contact a guy from the ITUT and to see if this work could be useful. And about the IEEE 101.2, several years ago, the previous draft is written by Daniel Popper, and there is a co-author from is from the Cisco, and I know the IEEE 101.2 is mainly provided by the company.
I'm sorry, so the previous, the POPA, author of the POPA draft participates in IEEE, is that what you're saying?
No, I mean, well, I mean, the IEEE 101.2 is related to Cisco, and I know a guy from the Cisco is the co-author of Daniel Papa's draft, and I think it should be useful.
Okay, so I think we need a little bit more
Yes,
explicit
yes.
feedback from them, at least awareness, but
Yes,
hopefully much more collaboration.
Yes,
Okay.
totally agree.
Okay, we can help with that.
Okay,
Yeah,
thank you.
Good point. Thanks. Yeah, we need to help him on that.
Okay, so thanks for listening.
We can give a little introduction. We have couple of, can you hear me on the mic? Okay. We have couple of draft related to fragmentation issues in 6LoWPAN. And in next 30 minutes or so, we are 20 minutes, we are going to have two presenters. One is Pascal, who has had a 6LoWPAN fragmentation draft for a while. And then another presentation is Carles. He had fragmentation compression, how to make it even smaller. So we are going to discuss these two, and then we are going to take opinion from the working group whether we need to work on such a problem, and whether we need to work on both of these drafts.
Okay, and we talked with the chairs, and we decided that my slot would mostly not be dedicated to talk about solution, but more to go through the primes that occur in a 6LoWPAN mesh network with fragments. So let's start, please. I won't go through that history. I only have 10 minutes, but there is a long history of issues related to fragmentation. So the last point is illustrated by the next slide. We have a experimentation in 6LoWPAN, which also tells us that across our meshes, we have primes with fragments. Next slide. There is a particular reason why I come here today with this draft, which is 6-ish. In 6-ish, we are using route over. And when you're doing route over, since the fragments don't carry the IP address, you have to recompose the fragments at every hop. And I will go into more details about the issues that this raises in the particular case of route over. Next slide. So the first and obvious primes we faced with fragments is when you've got a very constrained device, and we used to play with devices which had only one buffer capable of recomposing a full packet. As soon as you start recomposing a packet, and as long as you've not fully received this full packet, then the other packets that were transiting to this node were basically dropped. And that's something that Jorgen faced. And he wanted to understand why he had such a slow rate on his 6LoWPAN network. And he ended up developing a MIP to investigate that, and that MIP helped him find out that it was actually this exact prime, that the buffers were being used to recompose a packet, and there was no way to receive or relay any other packet during that time. That caused a major source of drop-in packet. Next, please. So there is no absolute best solution. We have a recommendation. I think it's 1 minute, the timer that's in 6LoWPAN in RFC 4944, which says basically you should abandon after that time. Well, it's very hard to fix that limit. There is no good solution. Either you make it very long, but in which case you may be dropping many packets in the meantime, or you make it very short, in which case there may still be a fragment in flight. So without any understanding of what's going on in the network, without any acknowledgement of any sort, it's very hard to figure out where you are in this condition. Yes, Julius?
So Julius Krobacek, have you considered simply when you receive a new packet, dropping the fragments instead of having a timeout? Just when you receive fragments of a new packet, you drop the old fragments.
Okay, so we are across a mesh. We may be receiving fragments from multiple sources, but yes, that could be, if we had, which we don't, a rule that says you send only one fragmented packet at a time, then that could be useful. That could
So
be
you
one.
haven't measured that, you haven't experimented.
No, that's strategy, but that we would have to at least update 4944 to say, hey, if you have one packet in flight, don't start another one. And then if you have a mesh, it might be that one packet actually passes the other one through a different path. So it might be that the other packet, even if the source makes it so that its own fragments are fully sent before it starts the next packet, it might be that the next packet takes a different path.
Well, if you have buffering space for just one packet, you're in trouble anyway. There is no good solution.
There is no.
So I think it might be worth experimenting with alternate solutions here.
So, next slide, please. So the second issue, which goes a little bit deeper into the mesh now, has to do with hidden terminal. So basically, and that was already present in the layer 2 meshes, but it's not a 6-dish prime per se. If you have several fragments which progress on the same mesh, and the mesh operates at a single frequency, which is not a prime for 6-dish, then it might be that the transmission by a node which is further down the path actually interferes with the transmission of the next packet, which is somewhere earlier in the path. And there is no way to know about that, and there is no control about it. The only thing we could do is have some form of policy in the source to say, hey, you should maybe insert some space between fragments, but then again, it's very hard to figure out how the network is operating and what the right space should be between fragments. Next. And if you don't choose well the number of fragments in flight, the same time as TCP, right? You should not have more fragments in flight than you have hops which relay them, because that would mean that you are actually bloating the network with your fragments. Again, there is no feedback from the endpoint. There's no feedback from the network. No way to know if you have enough fragments in the air and not too many fragments. Next. Even if you space your own fragments, there are other users of the network. So for some router in the middle of the network, it may very well be that all those fragments coming from all those nodes starts piling up in this particular middle point. And then again, since we have no congestion indication of any sort, there's no way to figure that from any of the sources, and even injecting spaces from a source will not help. Next. So back, as I promised, to the specific prime with route over. With route over, we have to recompose the packet at every hop so as to be able to route this packet. Now, there has been early suggestions for a long time. We've had suggestions on how we could forward the fragments, which comes with keeping a state from the first fragment so as to be able to forward the next fragments along the same path. That's basically what my draft is doing. I will show the benefits, but I will also show the pitfalls of not doing it right, and the reasons why we actually need to specify how to do it right. So next slide, please. So this is the current behavior in a real 6-dish network. So my time could be time slots here, or just every transmission. There is first transmission, second transmission. So you've got a sender on the left. I don't know if you can read it. Then router 1, router 2, and then on the right you've got a receiver. And time passes, so say I've got this packet and it's 3 fragments. So on time 0, the sender has the 3 fragments in memory. Time 1, the sender sends the first fragment and it's being received by router 1. Time 3, router 1 has received the 3 fragments. It can recompose the packet and start forwarding it again. But the first problem that you can see here is that means the space in memory in this intermediate router has to be for 3 fragments. And the second thing that you can see in this picture is the delay, the latency that it takes in this network to carry out this packet, which is 9 times. Next slide, please. Now, just if we think for a minute that we could be forwarding the fragments individually to the endpoint and wait for an acknowledgement from the endpoint to say, hey, you can send the next fragment, which would be, in theory, a solution to the buffer bloat problems that I've been discussing. Right? It would be very expensive, but just for the sake of, let's have a window of 1. If we have the worst case window of 1, we can see that it still takes the 9 times that we had before. But now the benefit is that we have reduced the amount of memory in the intermediate routers down to 1. Okay, next slide, please. And then if we do something a bit smarter and we start streamlining the packets and we provide the means for doing that, then we can actually reduce the latency as illustrated here. Right. So as the first fragment has progressed enough in the network, then the next fragment can be sent. So you may be telling me, hey, you're going to interfere with yourself, or you're back to this high hidden terminal issue between your own fragments. Well, true, depends on your network. If you're operating a 6-dish network, which is something some people here are doing, then since we are using tensor-stitch and hopping, there won't be collision between any of those scheduled transmissions. So this is actually very efficient on a 6-dish network. Okay, so next slide, please. And now we are down to, if we want to forward fragments, how to do it right. And I was talking about pitfalls, and we'll show one here. So maybe it will be better. It's all written here, but if we switch to the next slide, please. I will show it on, we don't have a pointer. So the problem with forwarding fragment is that you need a tag that you will associate to the state that you will keep inside the intermediate routers for the time of forwarding this packet. So you could be saying, hey, I can use whatever addresses I have in this packet, or I can use the datagram tag. Well, the IP address you can't because it's only in the first packet. The MAC address you can't because they are meaningful for only one hop. So you're down to using the datagram tag. Well, that's fine. That means my datagram, so I could just index my state with this datagram tag. Well, such thing, it doesn't work because the datagram tag is something which is uniquely significant to the source of the datagram, which is not the source of the packet MAC address. And it's not the layer 2 source, not the layer 3 source. It's just this intermediate router, which was the 6-LoWPAN compressor. And if this datagram timing is uniquely significant for that guy, and it could very well be that another guy on the right chooses the same datagram tag. And this router in the middle may be forwarding packets for those two datagrams. Now they are identified by the same datagram tag. Okay? And if you're in this situation, then you may be confused about forwarding the packet to destination A or destination B. So that actually tells us that as we do this forwarding thing, we should also think in the lines of MPLS. We should also think in the lines that this tag must stay unique, which means it must be locally significant to every hop, which means we need to swap them, just like MPLS does. It's no big magic, but that's a pitfall. If you don't think along these lines, then you may get two packets which come with the same datagram tag, and then you will confuse the destination. Next slide. Since we start building state in the intermediate nodes so as to forward the next fragments, there comes the need for cleaning them up. There comes the need for finding if the flow succeeded or not, if it did not, or whether it did or not. There's a time to clean up those states. If there is no acknowledgement of any sort end-to-end, then the intermediate routers can just time out this state. And this state can pile up. So this all pleads for a protocol with enough information from the other hand to know that your fragments went through, that some fragments were lost, in which case you can make a decision of retransmitting those fragments or dropping the packet, but at least you know. And when the transmission is finished, this flow can be used to actually clean up the states in intermediate routers. Okay, so, sorry?
Julius Krobacek, I'm sorry, I'm lost. Why do you need state if you're forwarding the fragments? Can't you just blindly forward them without any state?
Okay, so
can
you go back to the previous slide, please? And I'll just show you this. Okay. You're at layer 3, okay? So the first fragment carries the IP address, the other fragments only carry the datagram tag, okay? And so you're in this intermediate router here, and you see the IP packets, and you have multiple neighbors who could route the packets anywhere, right? Imagine these are routers. And so you see the first fragment here, and you say, oh, this IP address, my next stop is this guy. Now, you must keep a state so that when the second fragment comes in, you don't pass it to this guy or this guy, you still pass it to this guy. And the only indicator for this is the datagram tag in the packet. That's why. But if you do meshing at layer 2, you don't have this problem. Okay, so all I can say is from early experience in doing frame relay and ATM and all sorts of things, well, a number of the problems that we are facing here were highly predictable from the out of the internet and switch networks. So there's no big surprise. The solutions also exist in those networks like MPLS. I mean, there's nothing new there as well. Some of the issues could be worked out by issuing recommendation, but most of what I've been describing here cannot be done by just smart implementation or implementation recommendation. We have actually to define a protocol which we enable to install this state and clean up this state.
Gabriel Montenegro. So there's a lot of stuff that maybe works fine if you're mesh under, or if most of your packets are small. For example, if you have, it replace the word fragments by small IV packets.
Yeah,
A lot of these problems also happen, right?
Some of them, yeah.
Yeah, the blind terminal, whatever. A lot of these are common to that. So it would be great to not express the recommendations in a general fashion, but to really clarify where they apply. So these are problems that you will face in mesh under versus route over versus these are problems that are common for normal packet routing when your packets are small. And by the way, if you have a lot of fragments and you actually have a fragmentation problem, maybe the best thing is to rethink your application, because if you're using 15.4, you should use it for what was designed for small packets. So if you're already having fragments, maybe that's not your right link layer or your application is wrong. You may have fragments now and then, but most of the traffic should not have any fragments. So there may be also caution in those terms. When does it apply? When it could be a problem? Does it apply for all those problems you cited, all the issues? Which ones are something that apply for mesh under versus route over versus small packets versus exclusively for fragments versus, it would be good to clarify that.
Well, yeah, the problem is, you're perfectly right, 100%, I'm completely with you. There is no document behind the slides. This document, if there was one, would have to say exactly what you said. And I tried to hint that in one of my presentation. I said, this is mesh, this is route over. But there's no document that sustains those requirements. And I just presented, my document is a solution for the specific space of route over. And then it's just a solution. I'm not explaining why I'm doing it. I'm explaining how to do it. Right? I don't have a requirement document. Maybe this group would want one. And I would say mostly if there can be recommendations, at least I mentioned some cases where some recommendations could help alleviate some of that, and part of the recommendation was think your application right. It starts there, like you said, and then just space your fragments. But there's a limit to that. But my draft, for which I have presented all this, is specific to route over, and it's just a solution. I'm not saying why I'm doing it. That would be another document. I don't want to overload it with this.
Thomas is first.
Thank you. So I sent you a long, pretty detailed review, Pascal. I hope you received it.
Yeah, I saw that, but this was kind of busy week.
Yeah, for sure. Yeah, sorry, I sent it on Monday. So I want to like put myself really behind this draft. I think without this, the 6LoWPAN is almost unusable. I mean, as soon as you have a fragment, you have a real problem. Imagine, Gabriel, I get your point. If you have short packets and you fragment them in two fragments, you still have a problem. As soon as you start fragmenting, then if at every intermediary node you have to reassemble, you're not going to have 100K of RAM in there. So you might have one buffer for a full packet or two buffers. And then if you start losing a fragment, then how long do you wait until you clear the whole buffer? It's a recipe for very unreliable stuff. I've seen, I've asked a bunch of implementers how they did this, and most of the implementations they will just drop fragments, as they're filling up their buffer. So let me explain. I'm a node and I have two children that are sending me traffic, and they both are sending me fragments. Now, open source, the implementers I've talked to, what they do is as they go and fill up, as they are reassembling the first packet, because they only have one buffer, if there's another fragment coming from another node, from a different packet, they just drop it. These networks are unusable, and it doesn't matter how long your packet is, because you have, your buffer has to be long enough to account for, you know, a maximum sized packet, which is, you know, a little over a K. So, you know, without this fragment forwarding, you know, I might as go as far as saying that you cannot build reliable networks.
There's no question behind it, right? About going through all.
There's no question yet.
Which I will do later. Thanks.
Clarification, I wasn't negating the problem, I was just asking for some scoping.
Okay,
about
okay.
Where, in what network it applies more, etc. Recommendations, how to deal with it, etc.
But there's still room for what you're saying, right? There's still room for a document which we cannot tell.
Yeah, totally, of course.
Pascal, can you go back to one of your slides with the time sequence chart, please? No, sorry, my name is Michael Richardson. It's Wednesday morning. I can touch my nose. And no, sorry, further back with the chart.
Which one of
that one, for instance, that one. So I guess I don't understand. In the first box, the sender has an III.
It's just three fragments.
Oh, it has 3 fragments. It's not fragment number 3. Oh, these sequences make much more sense now. Okay, thank you. So, yeah, I get it now. It's Wednesday morning. So, so my question is do you think that, so the solutions that you're envisioning, I believe, involve wholesale changes to all the nodes in the network to do something amount of fragment forwarding?
Yes, they need to learn how to build a state.
Yeah.
And we say how you do it. So it's an MPLS operation using datagram tag as label.
So what I wondered was if there are devices that are slightly more capable, that have 2, maybe 3, maybe 5 packets worth of RAM, this is not such a big deal for them, right? And if you have a device and it has space for 5 to assemble 5 packets, for instance, then you could deal with 5 children that are sending, and you could not do what Thomas just said.
But you will be back to the first slide.
Back to the first slide.
Right. Not bloat means
Right.
latency. People in this room are used to this concept. Right.
So I'm agreeing with that point, and what I'm trying to understand is, could there be a solution where, and you're talking about creating state, which also implies that we have to have some way to store it, right?
And clean it up.
Okay, and code to do that. And so I'm wondering if there are some I wonder if there are some solutions where devices that have more buffer space can continue operating, and devices that don't have to do something new. And so now it becomes a kind of more of a trade-off between code space and RAM and other things, but that
it's in there. It works like that.
And we also don't have to we can incrementally deploy more capable nodes, or nodes that speak state, into the right places in the network, and not necessarily everywhere. And so I don't have an answer solution, but it sounds.
Well, you do, because this does it.
This does this.
That's because what you do is you take a fragment. Oh, Thomas.
Actually, folks, I just would like to remind that we are running short in time.
Okay.
So if you read my draft,
point is
it does it.
Point is that I think it would be nice if we had a way to get here without a forklift upgrade.
Oh, it's not. I mean, every node can decide to do it or not, right? So what you say is completely compatible with the draft, my draft, which I did not present as it stands.
I'm not sure who. Did Thomas raised his hand before Rolf was on the line?
I just want to ask
anybody notice?
Clarifying question. Can you confirm, Pascal, that I can run a network where I have some nodes that implement this and some nodes that don't, meaning the nodes that have a lot of RAM can be reassembling and then forwarding once it's been reassembled? Is that?
Yes, yes, because you don't know what the previous node did. I mean, you're getting fragments, you're switching the labels, and you're forwarding. If your node was the originator because he has reassembled, or because he was the first node, you have no clue. So yes, you can do exactly what you're saying and what Michael is saying. There's absolutely, I mean, the first node must operate. And when you're a router in the middle of the network, you don't know if the node before you was the originator or the first fragmenter or a reassembler which refragmented. You have no clue about it. So yes, it works. No problem. You seem puzzled.
No, it's fine. You answered my question. I'm done. Thank you.
Oh, okay. Ralph Drums. Pascal, in reading quickly through your document, I notice it mentions fragment retransmission and missing fragment, lost fragment recovery. I don't think you mentioned that anywhere.
No, because this presentation is not about my draft. My draft is a solution draft. I quickly said that if you acknowledge, then you can retransmit. But I did not go into these details here. My draft has it.
Well, so my question is about lost fragment recovery. Have you looked into the effect of fragment retransmission on upper layer congestion control, flow control, congestion avoidance algorithms?
Yeah, so if we go through my slides, we'll see that, yes, I will be asking for a transport layer review for this work, obviously. But it's not much difference to retries we already do in radios. I mean, 6LoWPAN work on 15.4. 15.4 does retries.
I understand it might not be that much different. I was just asking if you had already done that, had any idea whether it has an effect
We've
or
had
not.
that discussion, and we still want the same from transport.
Yeah.
But it's exactly the same story on a longer frame than the one we already know on radios. But yes, that was actually a point was raised when I presented those slides first.
Pascal, we are going to ask Suresh for a recommendation for transport layer reviewer, and then we're going to get it reviewed. And for the label, maybe we need more discussion in the solution, because how do you distribute the labels and how exactly?
They are self-formed by everyone.
We are running out of time. Just 1 minute, please. 1 minute.
Yeah, Casper, I have 2 quick points. One is we have been discussing this for approximately 8 years, and I think it would be really good to get some progress here in one or the other direction. So I believe we really need to be allocating time to do this. That's one point. The other point is we have been discussing this for 8 years, and there are solutions out there, and I'm not entirely sure that you have covered those. And so apart from seeing problems, and what Thomas said can be summarized as there are really bad open source implementations out there. Yes. Apart from that, yes, please.
I've not talked about solution, right? I've talked about problems.
Right. So I think one very important question would be, can we fix them in the code, or do we have to fix them in the protocol?
Yeah, and that in my slides I went through them rapidly, but I explained why the issues that they had could not be simply fixed by smart implementation or a of the existing standard or a recommendation from this group. I mean, some things could be improved by recommendations from this group, which means do your software this way, but some others cannot.
Okay, I think we have to shortcut the discussion short
I
now.
just want to mention that there are different views on this subject.
Okay.
Yes, Suresh Krishnan. So like Samita and Gabe, like if you think the working group is like interested in taking up this work, right? And then I will get the TSV to review. I'll get somebody to do the transport review. But there's another point I wanted to make. One of the things we're kind of encouraging the working groups to do is like explore alternate kind of meeting setups. Okay. So like I already saw like clusters of problems in this space. So if you want to consider like a different meeting setup for the fragmentation space, I could get you a room next time with like a whiteboard and like a smaller set of people. Okay. If that's something you want to explore, like, give me some problem clusters and we can actually get like meeting rooms, like maybe smaller slots with different setups, or like if you want like a U table or whatever, I think we can sit down. So because I know like, people have like very varying expectations from this meeting. So I don't want like some micro problem to hold up the whole group. So if you want that, we can separate it out. Okay.
Thank you. Yeah. And just a quick question. How many people think that the fragmentation in 6LoWPAN is an issue and would like to work on it? Sorry. How many people would like to work on fragmentation issues in 6LoWPAN? So next is Carles. Carles, you have to be really short and precise. We are running out of time. So if you can do it in 7 minutes.
Okay, so this is a presentation on some document which is was already presented in Seoul. So this is kind of a reminder. And the approach in this presentation is a bit different from Pascal's because this is about some solution for somehow quite a specific problem. So, okay, we have the original 6-loop fragmentation mechanism, which was defined in RFC 4944 with the need to support the IPv6 MTU requirement over 15.4 networks. Then there was the fragmentation header defined with a 4-byte header for the first fragment and 5-byte header for subsequent fragments. So this proposal I'm presenting today defines a 3-byte header, which is a little bit more lightweight and which in addition supports other technologies with even extremely short layer 2 MTU sizes, such as even just 4 bytes in the most extreme case. So this work was originally intended for LP1, where we have technologies with very short layer 2 MTU space. For example, in Sigfox, we have 12 bytes for the uplink, 8 bytes for the downlink. In LoRaWAN, sometimes maybe just 11 bytes. So the purpose was to define a new fragmentation header, which could actually work on this because the 6-loop fragmentation mechanism didn't work over this. Then this was considered in the LP1 working group. However, there's a different approach that has finally been taken and we'll present later in the LP1 meeting. And at the same time, folks suggested that this solution could be considered in the 6-low working group as well. By the way, there was one comment in Seoul about the name, the title of the document. So maybe optimized could be replaced by something like 3-byte, which is the current proposal. Next, please. So this is the format, which defines a 3-byte fragmentation header for both first fragment and subsequent fragments. Initially, there's for the first fragment a dispatch pattern, which tells that this is a first fragment. Then there's a datagram size field, and finally datagram tag. Then for subsequent fragments, the structure is similar. However, instead of the datagram size, we have the datagram offset field. So next, please. Well, these are the changes that have been applied in this proposal compared with the original one in RFC 4944 and the rationale for them. So the datagram size field is now here only included in the first fragment. So originally that information was included in all fragments. However, by doing this, the format still supports reordering, although with a little bit more complexity at the receiver side. Then the datagram tag field has been reduced to a size of only 1 byte. That's assuming that ambiguities due to wrapping of this field are possibly not so much expected, even if we have this size, because of the possibly low message rate that we might expect, at least in some of the scenarios we are considering. And the datagram offset has been increased from a size of 8 bits to 11 bits, which allows to encode the offset in increments of a single byte. So as a result, this format is simple. It is byte exact and short. It supports additionally layer 2 technologies with very, very constrained layer 2 payloads, such as 4 bytes only in the most extreme case. And as a result, also the overhead is reduced compared with using the original 4944 fragmentation header format. So here you have some analysis, some numbers on the degree of decrease in this overhead for different IPv6 datagram sizes and different layer 2 payload sizes. On the other hand, this format requires allocating 16 dispatch values. The first 8 are for the dispatch pattern for the first fragment. The last 8 are for subsequent fragments. No. So, well, just a quick comment about possible relationship with with Pascal's draft, in particular about the specific details about recovering fragments. So because he kind of solves a different problem, is increasing a little bit the fragmentation header size because of the need to be able to selectively retransmit fragments. So the idea is that, okay, that would deviate a little bit from this proposal. Okay, so what do you think as a working group? Is there interest to work on this proposal?
Okay, I have a comment, Suresh Krishnan. So the way I understand it, like there's, okay, so I'll ask it as a question. So when let's say there's reordering and the second fragment comes in first, how does the recipient figure out like how much of a reassembly buffer he needs? Because in the original 6-low-pan, right, the datagram size is always there. So whichever came first, like will figure out like how much buffer you need. So how do you figure it out? I read the draft and it's not in the draft. So what's the intent? Like how is it actually going to make this thing appear?
Yeah, so as you said, that's not yet thought, but that's something we might need to solve. Yeah, so that's related with the additional complexity that is needed at the receiver side, and that's exactly the point, to do something for the receiver to maybe make it easier to allocate some memory for reassembling. Yeah.
Okay,
so we need to work on that.
So, but it's going to be some sort of heuristic, right? So you need to specify how, like, you'll fail gracefully if like that doesn't hold true, right? Because you cannot make information appear from nowhere, right? If you don't send it, it's not there. So I think Gabe might give like probably better perspective because he might have historical perspective of why things are that way.
Yeah, so about the diagram size, we thought about that and we decided that if we wouldn't send it, then if you got a subsequent packet before our first packet, you had to assume the worst case 1280 and separate all that buffer space with this particular tag. That was the only thing we could think of. So in order to avoid that, there was a trade-off. I think the draft, the RFC actually talks about that trade-off. So we decided just to send, be explicit, because in the common case, it'll probably be less than that. And so it'd be good not to waste space and buffer space that much. So that's one decision that I think maybe still holds. It would be good to discuss. That one, I think, is still valid. The other one is about reducing the tag. I think that's still valid because we may face more wraparound and ambiguity problems given higher data rates than what you guys are looking at. So on those two main decision points that you departed from as related to 4944, I think for 6-low technologies, those two are still valid per 4944. But
yeah, so I think maybe it would be good to see if there are different requirements, considering maybe different scenarios, and whether maybe these points that we have discussed right now might not be such an issue in some specific situations, but I guess we might need feedback from people in this regard.
Any other questions? Anybody who has read this draft? 3, 4, 5. 5-ish. Maybe 6. Okay. And then coming to the list, I think at this point I'm not clear about whether it belongs in this working group, but it's definitely good to be aware of it. But it'd be good to have comments on the mailing list opinions about whether you think it belongs here or not. No, it's just, I think it's good information today. Thanks.
Next is Anthony.
Okay. Good morning. I'm Pat Kinney, Kinney Consulting. And this presentation was given yesterday at 6-ish, but I'm repeating it today. And I'm going to go somewhat fast because I think we're a little bit low on time.
Okay.
So those are the things I'm going to talk about. 802.15.4, which most people in here should know about. If not, ask questions. But then related standards, 15.9, 15.10, and the one that's being worked on right now is 15.12. Thank you. Okay, now how IEEE works is that when we do additions to a standard, we call them amendments. And all you do is the amendment only has the changes to the standard, to the revision, the latest revision. Right now, we have 4 approved amendments to 2015. N is a physical layer for China medical bands. By the way, this is the Chinese version of 4J. 4J was for the US and Europe. And basically think about as a gurney or a cart. Somebody's on it and they have a whole bunch of medical equipment around them. So it's kind of like a container where this, even though it's moving, all of the 802.15.4 devices are relatively stable to each other. So, and that's a medical band in the US, and now it's a medical band in China. The next one is ultra low power physical layer, and that one added amplitude shift keying. It's not interoperable with the other types of modulation, but they wanted to reduce the power even more. I'm going to skip down to Amendment 3. It's the use of the 865 to 867 band in India, so we just added that band. And then the higher rate 2 megabit per second physical layer is backward compatible to the existing 250 kilobit per second that most people in here are aware of at 2.4 gigabit. I'm sorry, 2400 megahertz. One thing to remember though, the largest frame that you can pack into that that standard is now 2047 octets. So it's not 127 anymore. In fact, most of the standards now coming out from 802.15.4 are 2047. Just to let you know. Change. We do have 2 amendments in process. 4S is basically for spectrum resource measurement. In other words, we're adding capabilities for a network manager to understand what's going on and how to best optimize the network. And so, by the way, so 4S will work very well with the standard 15.12, which I'll get into. So they're kind of a pair. 4V is just basically clean up and add some more bands in the sub-gigahertz area. Europe, Mexico, Brazil, and so on. Next. We have a core agendum for 802.15.4 2015. Little problems causing big issues. The 64-bit MAC address transmission order was changed in 2015 to be the same as Ethernet, same as 802.11. However, that broke. That broke 15.4, and so we realized that we can't be the same. So we're changing it back to the way it was. Also, there was a missing value for a company identification. It's used in a nonce when you're doing the short address. And you can just barely see it on there, but we have got the value. We will put it in the standard, but if you're doing something right now, BA 55 EC. And the estimated approval date, February of 2018 on that one. Next. Yes, we're doing another revision. We have about 1.5 amendments per year is our rate, typical rate. And revisions, we're doing them typically every 4 years. By the way, it's about the same as 802.11. So we're constantly revising. And start early is better than starting late. We're rolling up the 6 amendments, as I mentioned. We're including the core agenda and any other corrections. If you have other corrections, please let us know. Correcting ambiguities, we have a lot of them in there, and we won't correct them all, but we'll do our best. And then violations of the IEEE style guide, that just irritates the editors, so we do that constantly. Major effort, we're going to start that in July of this year, and that will be in Berlin. The estimated approval date is May 2019, 4 years from the last one. Next. Okay, key management protocol, 802.15.9. It's a recommended practice for a message exchange framework, as I mentioned up there. It uses information elements that were brought in on 4E but are now pervasive through all of 802.15.4. Guidelines for 54 usage of existing KMPs such as .1x, HIP, PANA, and so on. It also, though, adds 2 things that are pretty neat. It adds a general purpose multiplex mechanism. And we will use that, by the way, in 15.12, and I'll show you that. Defines some fragmentation and reassembly protocol. We just heard about fragmentation and reassembly, and we decided that we need another one. So we've added another one. So you can't have too many of those. Next one. Okay, layer 2 routing. This is obviously mesh under. It's a recommended practice. It defines protocols that route practices on packets in a dynamically changing environment. Order of a minute is what they're suggesting there. Extends, obviously, the area of coverage. Supports data concatenation, which is a great thing because that allows you more efficient use of the spectrum. And then supports small, medium, and large scale networks. By the way, there's a URL on a tutorial if you just want to see an overview on that. It's very informational and helps you just to understand what's going on there. Next one. Okay, 802.15.12. This is a project that's underway right now. I'm the chair, and Charlie Perkins is the vice chair of that. So if you see either of us around, please ask us questions. I did a presentation to 6TISH on a conference call on the 3rd of February. The purpose is to reduce the complexity in configuring and using a 15.4 device. As a quick one, the primitive for sending data on Ethernet. 4 parameters, sorry. The primitive for 802.11 sending data is 6 primitives. And the primitive for 802.15.4 is 28 and growing. So it's a lot more complex. We're going to change that, reduce that back down to 4 is what we're trying to do. Maybe 6. Additional higher layer protocol identification, ether types. And dispatch codes. We didn't have them before. So before you could only have one application or whatever sitting on top of 15.4. Now you can have multiple. Fragmentations of L3 datagrams, I've already told you about those. Harmonization of L2 protocols. Before, well, we have 6LoWPAN, we have 6TISH, we have KMP, as I mentioned, and we have L2R. We're harmonizing all those so that they can work together. And then management of 802.15.4 managed objects. Well, when we started back in 2003, there were no managed objects because we didn't think anyone needed to manage 802.15.4. We were wrong. And so we're adding it now, and we'll be adding the capability to network manage those. Okay. Updates since that last 3rd of February conference call. Configuration and network management.
1 minute left.
I'll be even quicker. Okay, I'm sorry, but can we go back to that last one? No, I'm sorry. Go forward. There, that one. This is an overview, and for some reason the picture didn't come out right. But down here, that's 802.15.4. Up here is 802.15.12. Okay. Next slide. Configuration. We're working on that. A concept of profiles, where a profiles is all the configuration data necessary for 15.4. And you'll have a lot of them so that you can actually switch from configuration for this application to that application. So that'll be very, very helpful. Management protocol module will do that. We're looking at using the Yang data modeling and growing consensus for a protocol such as NetConf, so we can have a full application programming interface. And then network management, well, why not just use a NetConf? And of course, we'll, as I mentioned before earlier, we'll use the 4S objects. And that should be it, right? Oh, participation. We need participation. We need help from you guys. So please think about joining. You can join via email, via conference calls, or you can attend a conference. Email reflector is right up there. Conference calls, we haven't set them up yet, but we'll do that when we have people asking for them. And then conferences, the next conference is in Daejeon, Korea in May, but we also have one in Berlin, Germany, the week before IETF. So it's a short drive.
Thank you. Thank you, Pat. And we had one last item, but we ran out of time. But if you'd like to run the 6-low plug test along with 6-ish in Prague, please contact either Karsten and Harry. And also please keep chairs involved.
Blue sheets, please.
Everybody signed blue sheets?
Thank you.
Oh.